All right, welcome to screencast number 2 for the final competition robot. In this screencast, I'm going to be showing you some of the steps that I went through to create this. This is a CAD model that's very similar to the prototype that I made as an example for the final competition robot. Just a brief overview of it. There's a 1/2 inch thick sheet of plywood. It's used as a base. There are two 1/8 inch thick 1 inch by 1 inch angles that are used as these vertical supports. You'll see there's a motor, a sprocket, a small sprocket attached to it, a large sprocket attached there, and then there is sheet metal, 2 different parts of sheet metal used for an arm and for a scoop, as well as 2 other pieces of sheet metal that are used as brackets to help hold these vertical supports together. Oh, I guess there's also an axle up there. So I'm going to show you this in itself is an example. I'm going to show you an example of how to make 2 of these specific parts. And really what I want to be highlighting here is that when you are designing things for the final competition robot, you have to make them out of actual materials that you actually have, such as the base of your robot might be made out of 1/2 inch plywood. So in your CAD model, it should be 1/2 inch thick. It should look like wood. These vertical supports are made out of the 1 inch by 1 inch angle. That's 1/8 inch thick, and it's made out of aluminum. The sheet metal is roughly 1/16 of an inch thick, also made out of aluminum. So I'm going to show you how to make a couple of these parts. Okay, the first thing I'm going to show is how to make these vertical supports, the things that look like L's. So we're going to do a new document, file new, make a part. And the first thing we're going to do is extrude boss or base. I'm going to do this on the top plane. And what I'd like you to picture is imagine looking at that angle from the top. What would it look like? So if we go back to our prototype assembly, if we looked at this from the top, zoomed in, it would look like an L. The L would be 1 inch by 1 inch. It has a thickness of 1/8 of an inch. And then this line itself would be a little less than 1 inch because of the 1/8 inch thickness there. So 1 inch, 1 inch, 1/8, 1/8, and then somewhat less than 1/8 for both of those two. So that's what we're going to start off by drawing. So I'm going to start by drawing a 1 inch line. Click, click. If I am very patient and just click without moving the mouse, I can type in 1 inch. And I can't really point to you and show, but on the left-hand side under parameters, I typed in 1 inch. Another option is to use the Smart Dimension tool after each one. You can click and type in 1 inch. All right, I already did 1 inch there. All right, next line. I'm going to do the other vertical line. From there to there, I'm going to type in 1 inch. Check mark. I'm hitting escape to get rid of the line. Check mark. There we go. Next, I'm going to draw from here to here, and I'm going to type in 1/8 IN for 1/8 of an inch. And that'll do the math for me to figure out what that is in decimal form. It should be 0.125. But just type in 1/8 of an inch and then check mark. Okay, next, I'm going to do another line here. I'm going to show you the Smart Dimension tool, should you want to do that. Let's go up from there and hit escape. Select Smart Dimension, select that line, drag it over here, and now I'm going to type in 1/8 of an inch. Now, to finish this, I shouldn't have to add any more dimensions in. I can go over, and it's going to stop when it's vertical. There we go, and I'll do another line right there. Okay, and I hit escape to get rid of that line. So what I've just done is I've drawn an L. This is the 1 inch by 1 inch angle. That's 1/8 of an inch or 0.125 inches thick. Exit sketch. In my drawing, this was a 6 inch tall support. So there we go. Check mark. And then last thing, this is gray, so it could pass for metal, but I'm actually going to go in here and select appearances, metal, aluminum, and it doesn't matter what you pick. How about polished aluminum? Looks fine. All right, so that's an example of how to make the angle. I'm going to do one more example with sheet metal. So let's see. I called this the 6 inch. Let's see. I called it vertical support. Version 2. Later on, I went back and made holes in this so that there's a place for the axle to go through. But don't worry about that for now. Okay, let's see, one more. So File, New part. Let's go back and look at our CAD assembly, the prototype assembly. I'm going to do this, how about I'll do the scoop. The scoop itself is 2 inches tall, 4 inches long, and it's made out of, and it's 4 inches wide, I believe, and it's made out of 1/16 inch sheet metal. So in this case, I'm going to zoom in from the side here. I'm actually going to, when I'm drawing it, I'm going to draw this side, this face that looks like an L, 2 inches tall, 4 inches long, 1/16 inch thick there. So it's kind of like what I just did, but some slightly different dimensions. So going back to my new part, I'm going to, I think I already did extruded boss base. I'm going to sketch this time on the front plane. Doesn't really matter, but that's the orientation that it's going to have. I should have selected side plane. That's similar to the orientation it's going to have on the final assembly. And then here we go. Let's draw some parts. So it goes up 2 inches. I'm typing in 2 in. Oh, something wrong. Escape, delete. Okay, let's smart dimension that. Did not do well. 2 inches. Okay, I'm going to go over 4 inches. I'm typing in 4 4 inches. Now I'm going to go up. This time at 1/16 of an inch. That's how thick the sheet metal is, roughly. And check mark, escape. Now I'm going to show you another trick for this. Instead of doing this next line, which I could, I'm going to go from here over. I'm going to make sure this line is horizontal. I don't really know what the measurement should be. So smart dimension. I don't know what the fraction or decimal is off the top of my head. But SolidWorks can do some of the math for me. So I'm going to go 4 minus 1/16. That should be 3 15/16. But anyway, it will figure this out for us. It's 3.94 inches. Good. And then we'll keep going from there. A line from here to the top. Now if you zoom in, you can see that it's defining this. You can choose to make this line lined up 90 degrees with the other point. So there we go. And there we go. Escape. We have that L shape. It's 1/16 of an inch thick. All right, now I'm going to exit sketch, extrude. I've forgotten how wide we said. I think it was 4 inches. Check mark. Let's make the appearance aluminum. How about brushed aluminum? Doesn't really matter. There we go. Now that's just an example of how to make a piece that will be made out of sheet metal for your actual assembly. Okay, so I'm showing this as an example of what your CAD model will look like. Something else I will point out is that a number of these things will need to be fastened together. Right? You'll probably need to drill holes in these brackets and screw them into the wood with wood screws, or drill holes or hole punch into this bracket and the vertical support and use a rivet to rivet it together. Same thing with these. These sheet metal pieces should be riveted to get together. I might need a screw to go through into the gear, or maybe some bolts. Often in the CAD models that we are going to be developing, we are going to ignore those fasteners. So don't worry about making holes for rivets and things like that. You can make that in the shop. That'll be fine. This is a really good way, though, of finding out how things will fit, and also helping you make decisions about the feasibility of making your robot. Thank you for watching this tutorial. Good luck.